Alright students, you are welcome to this module of home tutors. In this module, we will be looking at quadratic equations. And I am your instructor, Kayode Babatope. In this module, we will be looking at the following outlines. We will be looking at the general representation of quadratic equations. We will look at the factorization method of solution. We will look at the method of completing the squares. Alright? Because there are generally 4 different methods for solving quadratic equations. One of them is the factorization method. The other is the method of completing the square. The other is what is popularly known as the using of almighty formula. And then we will also look at the graphical method for finding the solutions to quadratic equations. We will go further to look at some equations that are called simultaneous quadratic equations. Also, we would be looking at word problems that lead to quadratic equations. Then we will look at symmetric properties of roots of quadratic equations. And finally, we will look at solutions to some past examination questions. I welcome you to this module, and as you've seen, this module is quite loaded. I wish you a very interesting time. I will do my best to give detailed explanations of each of the terms and concepts you are going to come across in the course of this learning material. But I want you to take note that listening to this CD just once may not give you access to the best. You need to endeavor to listen to it again and again. The more times you go through it, the better understanding you are going to be having of the solution techniques that are used in solving the problems. So don't make it a once and for all affair. This DVD belongs to you. So listen to it, create time to listen to it again and again. And I want to assure you, if you understand everything that is in this DVD, you will be able to solve any and every question related to quadratic equations. Now let's move on. A quadratic equation is generally represented as given below. So this is the general representation of what is called a quadratic equation. Ax squared plus bx plus c is equal to 0. Descriptively, the ax squared is called the squared term, the bx is called the middle term, and c is called the constant term. So equations of this form are known as quadratic equations. So therefore, descriptively, a quadratic equation is given as a squared term plus a middle term plus a constant term is equal to 0. The key identifying characteristic of a quadratic equation is that the highest power of the variable is 2. In this equation, a, b, and c are constants. The variable in this equation is x. And this equation is called the quadratic equation because the highest order of the variable, that is the highest order of x, is 2. That is why it is called a quadratic equation. That is, in a quadratic equation, the highest order of the variable is a squared term, that is 2. The solution to this type of equation will be those values of the variables which, when substituted into the equation, gives 0. And these values are termed the roots of the equation. What are we saying? We are saying that the roots of this quadratic equation are those values of x, which when you substitute them into this equation will give a value of 0. And those values of x are referred to as the roots of the equation. So the solution methods of this kind of equations involves finding the roots of the equation. And there are about 4 methods of solutions to quadratic equation. These are the factorization method, the method of completing the squares, using the almighty formula, and then lastly, the graphical method. Firstly, let's start with the factorization method. Factorization involves breaking a quadratic equation into its linear components. Linear components meaning that instead of having an equation that has an order of 2, we want to break it down into component parts with variables only of order 1. Okay, so for example, the equation x squared plus 3x plus 2 equals to 0 can be rewritten as x plus 1 into x plus 2 equals to 0. Okay, now this equation has been rewritten in terms of 2 linear components, because here we have x, here we have x. We no longer have x raised to power 2. Okay, so factorization involves breaking down a quadratic equation into its linear components. So one easy method of getting solutions to a quadratic equation is to factorize it. However, take note that not all quadratic expressions are factorizable. However, in order to test whether a given quadratic expression is factorizable or not, what we use to test is to calculate the value of b squared minus 4ac. Take note that b is the coefficient of the middle term, a is the coefficient of the squared term, and c is the constant term. So when you take the coefficient of the middle term, the coefficient of the squared term, and the constant term, and you perform the operation b squared minus 4ac on it, you can use that to determine whether the quadratic equation will be factorizable or not. Now the equation ax squared plus bx plus c equals to 0 will be factorizable if the value of b squared minus 4ac is a perfect square. What does a perfect square mean? A perfect square is a number which has an integer square root. For example, 9 is a perfect square because the square root is 3. 3 as an integer, it does not have any decimal place. For example, 10 is not a perfect square. For example, 25 is a perfect square. Okay, so let's look at this example. 2x squared minus 3x minus 9 equals to 0. Let us test if this expression is factorizable or not. Take note, the way to test whether it is factorizable is to calculate the value of b squared minus 4ac. In this expression, a is equal to 2, okay, the coefficient of the squared term. b equals to minus 3, that is the coefficient of the middle term. And c is equal to minus 9. c is equal to minus 9, that is the constant term. Okay, therefore b squared minus 4ac will give us minus 3 squared minus 4 times 2 times minus 9. Take note that c is equal to minus 9. Okay, c equals to minus 9. So you have minus 3 squared minus 4 times 2 times minus 9. That gives us 9 minus 72. That gives us 9 plus 72, and that gives us 81. 81 is a perfect square because the square root of 81 is 9. Alright, 81 has a square root which is an integer without a decimal place. So therefore, the expression 2x squared minus 3x minus 9 equals to 0 is solvable using the factorization method. Take note, not all quadratic expressions are factorizable, but you can determine whether a quadratic equation is factorizable by calculating the value of b squared minus 4ac. where b is the coefficient of the middle term of the quadratic equation, a is the coefficient of the squared term of the quadratic equation, and c is the constant term of the quadratic equation. Check another example. X squared plus 3x plus 2 is equal to 0. Is this expression factorizable? Let us test. In this case, a is equal to 1 because 1 is the coefficient of the squared term. A is 1. B is 3. 3 is the coefficient of the middle term. And C is 2. This is the constant term. So when we do b squared is 3 squared minus 4 times a times c. That gives us 9 minus 8, which equals to 1. Take note that the square root of 1 is 1. Therefore, 1 is a perfect square. And so, this expression can be solved using the factorization method. Now, let's look at another example. Look at the equation 2x squared minus 3x minus 1 equals to 0. In this case, a is 2, b is minus 3, and c is minus 1. So if we do b squared minus 4ac, we will have minus 3 squared minus 4 times 2 times minus 1. That gives us 9 plus 8, which equals to 17. 17 is not a perfect square. 17 is not a perfect square because the square root of 17 is not an integer. It is a real number, that is, a number with a decimal part. Therefore, this quadratic equation cannot be solved using the factorization method. I think now you understand how you can find out first whether your equation can be solved by the factorization method. Now, for equations like the above, which cannot be solved with factorization method, other methods can be used. Method of graphical solution, methods of almighty formula, or perhaps methods of completing the squares. Now, for quadratic equations that can be solved using the factorization method, let us look at the rules for factorizing the equations. Now, when you are given an equation like ax squared plus bx plus c equals to 0, and you confirm that this expression is factorizable after calculating the value of b squared minus 4ac, then the following rules are applied during the factorization. 1. Multiply a and c, that is, calculate ac. I hope you still remember what a and c are. A is the coefficient of the squared term, while c is the constant term. Okay? So, calculate the value of the product a times c. 2. Find two numbers which, when added or subtracted, will give b, but when multiplied will give the product ac. Alright, what we are saying is this: after calculating the value of a times c, you now have to look for two numbers such that when you add up these two numbers, the sum of the two numbers will give you b. B, remember, is the coefficient of the middle term, whereas the multiplication, the product of these two numbers, must give you a times c. I hope you understand, but even if you don't, when we get into the examples phase, I'm sure you will get it clear. The third point is this: now rewrite b in your quadratic equation with the two numbers that you have just discovered, and then lastly, group and split the resulting equation into linear fractions. NB, if well done, a check is that the two terms in brackets will be the same. For example, factorize 2x squared minus 3x minus 5 is equal to 0. in this example, a equals to 2, okay? That is the coefficient of the squared term. B is equal to minus 3. That is the coefficient of the middle term. And C equals to minus 5. That is the constant term. So therefore, B squared minus 4AC is equal to 49. Okay? And 49 is a perfect square because the square root of 49 is 7. It's an integer without a decimal part. So now, we have confirmed that this expression can be solved using the factorization method. We can now go ahead to do the factorization. The first step says, calculate the value of A times C. Remember, A is the coefficient of the squared term, while B is the coefficient of the middle term, and C is the constant term. So, we are told to find the product AC. So in our case, A is 2, C is minus 5. So the product AC is minus 10. Now, the next point says, look for two numbers whose product is minus 10, but whose sum is equal to minus 3. Remember the rules. First, multiply A by C to get AC. Second, look for two numbers which when you add them will give you B, but when you multiply them will give you the value of AC. Okay, in this case our AC is minus 10. So which two numbers is it that when you multiply them you will have minus 10, but when you add them up you will have minus 3? I think these two numbers are 2 and minus 5. So it is in finding these two numbers that really rests the skill in solving quadratic equations using factorization method. Why? Because 2 plus minus 5 will give minus 3. Okay? And 2 times minus 5 will give us minus 10. So now we have looked for two numbers which when multiplied will give us the value of A times C, and which when added will give us the value of B, which is minus 3. So now the next step. Okay, so now that we have found the two numbers, the next thing is now to rewrite B. Okay, remember we are now supposed to take the third point, which is rewrite B in terms of the two numbers that you have found. Now B in our equation is minus 3x. So minus 3 can now be written with in terms of minus 5 and plus 2. Okay, so instead of minus 3x, what do we have? We now have 2x squared plus 2x minus 5x. All right, because 2x minus 5x is actually equal to minus 3x. So we have broken down minus 3x into plus 2x minus 5x. And then you put the last term, which is the constant term, minus 5. We have rewritten our expression, our quadratic expression in another format, where 3x has now been replaced by plus 2x minus 5x. Why did we replace minus 3x with plus 2x and 5x? We know that also minus 4 and plus 1 will give you minus 3. However, when you multiply minus 4 and plus 1, it does not give you the product of A times C. It does not give you minus 10. Okay, so those two numbers you are looking for must satisfy two conditions. Their product must be equal to the value of AC, A times C, which in this case is minus 10, and their sum must be equal to the value of B, which is the constant term here. Okay, so in this case, we obtain two numbers 2 and 5. So all you need to do is to rewrite the middle term in terms of the two numbers that you have obtained. So instead of minus 3x now, we replace it with plus 2x minus 5x. So right away now you can factorize. Alright, you can group these two terms and factorize. If you factorize these two first terms, you will have 2x into x plus 1. Then if you factorize the remaining two terms here, you will have minus 5 into x plus 1 equals to 0. Okay, so now what you are going to have, this is x plus 1 in the bracket, this is x plus 1 in the bracket. All you just need to do is to take one of them, x plus 1, and then the numbers that are outside the bracket, you take them together. So this now gives us 2x minus 5 in one bracket into x plus 1 in another bracket equals to 0. So that is the process, okay? After getting to this point, you now take them in pairs. You can take any pair. You will still get the same answer. Okay? So, but for convenience, let us pair the first two. So if you take these two and you factorize, you will have 2x into x plus 1. And if you take the last two and you factorize, you will have minus 5 into x plus 1. How did we get plus here? Take note that by the time you are using minus to factorize minus, you definitely must have plus inside. So that when you expand, you can now have minus 5, and then minus 1 times plus 1 will give you minus 5. Because if you put minus here, by the time you expand, this expression will give you minus 5x plus 5, which will not be correct with what we are trying to factorize. Okay? But then I'm sure you don't have problem with factorization because this has been thoroughly dealt with in GSS classes. So I suppose that you are able to factorize this expression. If not, you may need to brush up your competence in this area of factorization by consulting our JSS module on factorization. Having obtained this expression, what you now need to do is to equate each term. Now, our quadratic equation has now been re-expressed in terms of linear expressions. Because here now, the highest power of the variable x is 1. You are dealing with linear expressions now, no longer quadratic equations at this point. So another thing to now note about the quadratic equation is that it is equated to 0. So even after factorizing, the linear factors must be equated to 0. Take note that if the product of two real numbers is 0, then either one or both of the numbers must be equal to 0. That is, in general, if A times B is equal to 0, then either A equals to 0 or B equal to 0. Alright? So therefore, what this means is that after factorizing a quadratic expression, the linear factors we obtain must be equated to 0 in order to obtain the roots of the equation. And these roots of the equation are also called the zeros of the equation.